Hello, hello. Hello, everyone. Am I audible? I hope I'm audible. Oh my god. Hello, hello, hello. Okay. So, continuity and differentiability on your demand. Limits we have done. This is the reason we did limits earlier. There is some voice issue. Let me check. Hello, hello. Okay, all good. So, this is the reason we did limits first. Without limits, we could not go ahead with this topic. Nishit, hello, how are you? All good? Having fun? Great. So, for those who are going to watch the video on in a day or two, or who are watching today live, I hope you got the information about the pattern change in JEE Mains. Got right? Everybody got the information about pattern change in JEE Mains? Hmm? JEE Mains pattern is changed for 2025. Although I'll talk about it separately, but still to research about it now out of earlier from 2019. Since 2019 we had to do 5 questions out of 10 integer type, right? Numerical questions. Now you'll have to attempt all 5. There'll not be choice. I'll explain this in a separate video. Don't worry about it. Nishit is saying, sir, I'm not able to study efficiently. Sir, how can I come in rhythm? Nishit, how can you come in rhythm? You know, discipline is not something that somebody else can give you, Nishit. Make a task list in the morning. The general habit which what should I say, every adult follows. If you ask any professional, anybody, any aspirant also, if you ask, they have written down in the morning and they'll stick to it. You stick to what you're supposed to do. You write that down in the morning itself. Write down. Today I'm going to do this chapter of maths. I'm going to watch this video. I'll be uh, I'll be solving these many questions from maths. I'll be solving these many questions from physics, from chemistry, this thing. Today, what you are going to do, just think about it and do it on the same day. Don't run away from it. Don't procrastinate. Procrastination is going to become a habit for you. Everything we do becomes a habit. Trust me. Everything we do on daily basis repeatedly becomes a habit. So be very careful what you're doing on your daily basis. Right, if I have a habit of sleeping till 9 o'clock, it's not going to be easy for me to wake up at 7 o'clock or 6 o'clock or 8 o'clock. It's not going to be easy. So make a habit of doing what you're supposed to do on the daily basis. Then we cannot do anything about it, Nishit. If you are going to study, then these things are going to be distraction. I cannot help you in that case. I'm so sorry. If that is the case, no, only she can help you. Okay, so let's start with our topic of the day: continuity and differentiability. And you can see that I've written part 1. Part 1 means that that we'll be doing this chapter in 2 parts. First, continuity, and then differentiability. So today we are going to cover up the continuity part. Okay, Before starting this chapter, I have a disclaimer for you that revise your limits very well. This chapter is only about limits. Only about limits. If you have not done your limits chapter, then I would recommend first start with limits. Okay, revise the limits, the standard formats in limits, not entirely. You don't have to solve each and every question that you have in your exercise or whichever book you're following, but at least the standard formats of limits should be thoroughly revised. Standard formats should be thoroughly revised, not series. If not series, at least the standard formats should be thoroughly revised. Okay, so this is going to be the continuity part today, and in the next part, maybe tomorrow or on Monday max, we'll be doing the other part of this chapter, which is differentiability. Continuity and differentiability together form good question. It's not that always you'll have a question which will be merged with continuity as well as differentiability. You can have a separate question on continuity also, but yeah, they'll involve limits everywhere because continuity itself means limits. Now let's start. Yeah, I'll try to keep this chapter short because I'm seeing that I'm getting this feedback that because of the long chapters, the students are losing focus and they are not able to study all together in one part. So that is also one reason I didn't want to keep this long by including both continuity as well as differentiability. So let's do in two parts, not a problem. After that, we can do integration also. Now, what is continuity? Generally, the perception among students is it is a very scary chapter. Continuity, differentiability, terms itself are looking horrible to me. No, it's not a scary chapter at all. It's very easy. If you understand the concepts and if you are thorough with limits, this chapter is not going to bother you because concept, if we talk about concept, there is just one concept in the entire chapter. Concept, like if we talk about the other chapters of ours, if we talk about straight lines, coordinate, AOD and all, so many concepts were there. We had to remember so many concepts. Here you don't have to remember any big number of concepts, only one concept max, and variety of questions is also of two types, trust me. So we cannot call this a difficult chapter. Okay, certain topics, fix only very few topics. Continuity at a point, need to check continuity at a point. Continuity of a composite function, continuity in an interval, and there are different types of discontinuity. We'll discuss that where the function are discontinuous. Now as we're talking about continuity with graph, you can easily understand. Self-induction. Continuity by graph you can easily understand. If suppose if I'm talking that this is A and this is B and my graph is smooth between A and B, I can say that my function is continuous between A and B, right? I can say that this smoothness of the graph says continuity. For example, if you remember the graph of greatest integer of x, if we plot this graph, you remember, right? This graph is somewhat like this. It breaks, it keeps on breaking. Graph of tan x keeps on breaking, right? So wherever graph is breaking, that means function is discontinuous at that particular point or that particular interval. Correct? Simple thing. In simple terms, if you want to understand, smooth graph means continuous. Breaking, jumping graph means discontinuous. Nishit, I think you should pay attention more on studying first rather than these type of questions. Okay, let's understand mathematically how will we say that a function is continuous or not. Or let's see some graphs first. Before coming to that, let's see some graphs. Now, can you see that this graph, if we talk about continuity of this particular function at A, is this function looking smooth to you? No. This function looking smooth to you? Yes, this is smooth, but this is breaking at A. At A, it is not defined. At A, it is defined, but the function is breaking at A. It's not smooth at A. There is a missing point. Over here, we can call this function as continuous because at A, it is continuous. It is smooth at A. Okay, it is not breaking at A. Correct? Pinky and Nishit, if I think you guys have each other's WhatsApp numbers, so you can talk there or on Instagram. This is not, I think, a perfect platform for this kind of thing. Okay. Now, mathematically, what it means? Mathematically means continuity means that we remember in limits we understood this, that in limits we understood that limit of x tending to a. How did we check this? Right? If we talk about this particular graph only, limit of function at x tending to a will be RHL, LHL. We'll have two type of limits, RHL as well as LHL. Correct? If you remember the limits chapter, we said that if LHL at A is equal to RHL at A, and both of these are equal to function's value at A, which is this case. LHL at A is M, RHL at A is M, and function's value at A is also equal to M. All three are equal. That is why we are saying that this graph is continuous. This function is continuous at A. That's what we are trying to say. That's what we studied in limits. And that's all you need to know about continuity. You'll be able to attempt, you'll be able to understand the question if you understand this particular part. What does continuity means actually? This is what you're supposed to know. You can make a note if you want to. A function is said to be continuous. Now let's come back to this part. A function f of x will be said to be continuous. It will be called continuous if its limit at a is equal to its value of the function at a. Right? If my function is supposed to be, is found to be, or is asked to be made continuous, or it is said that it is continuous at a, that means, it simply means in mathematical terms that its limit at a is equal to the value of function at a. Its limit at a means what? Limit means left hand limit and right hand limit at a. X tending to a minus means left hand limit. X tending to a plus means right hand limit. And f of a means value of function at a. So if these three things are equal for a function at a, that means that function is continuous at a. Right? This only is explained graphically over here. Now at a, if we see the left, if we approach towards a from the left hand side, that means we are finding the left hand limit. Left hand limit means approaching towards the function from left hand, approaching towards a from left hand side. If we approach towards a from left hand side, what is the value of the function that we are getting? From left hand side, if you see LHL over here at a, LHL means approaching from this side. What is the value that we'll get? Will be equal to n. RHL at a, what will be RHL at a? It will also be equal to n. If we approach towards a from the right hand side, it will also be equal to n. Will it be? No, this is going to be equal to m. If we approach towards from the left side, the value of the function will get is m. And if we approach from the right side, the value of the function will tend to n. LHL and RHL itself are not equal. So definitely this graph is not continuous. If LHL and RHL are equal, suppose in this case, if we approach towards a from left hand side, that means my left hand limit is going to be equal to m. What will be my right hand limit? If I approach towards a from the right hand side, where the function will be? Right hand limit will also be equal to m only. Right? From right hand side also, if I approach, I'm tending towards m. Right? Limit at a means LHL and RHL Nishit. Okay. Now from left hand side, if I'm tending towards, if I'm approaching a, my function's value is approaching m. From right hand side, if I'm approaching towards a, my function's value is approaching towards m only. LHL and RHL are equal, both are m. But what is the value of function at a? Value of function at a is defined here. Here there is a void, there is a missing point. Here there is a void. Value of this function at a is equal to m. So is this continuous? No, it is not continuous. It is not continuous at a. We cannot say it is continuous at a. This is what we are going to check in the entire chapter. Continuity at a point. Right? We are talking about continuity at a point. Whether the function is continuous at a point or not. How to know that? Check the left hand limit and the right hand limit of the function at that point, for the function at that point, and then check the value of function at that point. If all the three entities that we get are equal, that means we can say that my function is continuous for x equal to a. That means at point a. Simple to understand. Not a very complicated or constructed or confusing concept, right? Simple concept. Now, if we look over here, my LHL, if I tend to a from left hand side, my function's value tends to m. If I approach a from the right hand side, my function's value tends to m only. And my function's value at a also my function's value is m. All three are equal. So this particular function is continuous. I'll call it continuous at a. X is equal to a. Okay, this function is continuous at x equal to a. This function is not continuous at x equal to a. This function is also not continuous at x equal to a. Now suppose you can have different type of graphs, right? Suppose you have something like this. Continuous at x equal to a. Suppose this is a. Not continuous. There is a void, right? At x equal to, here left hand limit, right hand limit might come equal, but value of the function at a won't be equal. Suppose your graph is somewhat like this. This is 0. So function is not continuous at x equal to 0. We can say that. So graphically, you should be able to understand smooth graph at that point means it is continuous at that point. Continuity is there at that point. If not smooth, that means continuity is not there at that point. That's it. I'm not kidding. I'm not seriously not kidding. Believe me, that's all about it in continuity. That's all about continuity. I don't know why many folks which I meet are generally students which I meet are generally will be like, sir, continuity differentiability chhod diya. We left it. Vanda sir, no need. Without any reason, just by looking at the question, they will be like, this involves limits, this involves so much of types of functions. Duck, duck. No, you revise your standard limits. Limits is a small chapter. Okay, revise that and jump on to continuity and differentiability. You'll be easily able to do it. Don't worry about it. Simple concept. Okay. Now, if we look at these points, some simple points, if we understand these, we have understood continuity by looking at its graph or according to a function. A polynomial function. Polynomial function is always smooth. Does it break anywhere? Does it break anywhere? No. So polynomials are everywhere continuous. You check at any point, they'll be always continuous. Correct? Polynomial function will be always continuous. Linear, binomial, quadratic, trinomial, biquadratic, however you want to, cubic, any polynomial. They're always continuous, right? You can see that. Polynomial of x at a. Polynomial of x. Polynomial is always continuous. That's what I'm saying, Rishit. It's always continuous. If you see the graph of, let's say, quadratic, it will be like this. Is it breaking anywhere? Any point where it is breaking? No, not going to break. Of a cubic, if you see, is it breaking anywhere? No. Right? So polynomials will forever be continuous. We can directly say that. If we see a polynomial function and the question asks about its continuity, then what will we say? What will be our comment? Continuous for every real x. Continuous for every real x. Okay. Nishit, this is the problem. We are doing continuity and you're focusing somewhere else at some different things only. If this is the scene, then how will you get the rhythm? Huh? How will you get the rhythm? Okay. Ask in the end. I'll tell you how to prove that. That was easy when I remember this question. Y is equal to a to the power x. Y equals a to the power x. Huh? How will be the graph? Think about its graph. Try to recollect its graph. Will it always be continuous? Can we say that? Y equal to a to the power x, where a is greater than 1. Something like this, right? Right? This will be a. So it is not going to break anywhere. It's not going to jump anywhere. Forever continuous. Others also, y is equal to log x base a. If you remember the graph, same, continuous only, forever continuous. It will not going to break for x greater than 0, right? For x greater than 0, a greater than 1, x greater than 0, definitely, right? So this is always going to be continuous. How is mod x graph? Mod x graph, y is equal to mod x. How does it look like? It is always continuous, never going to break, right? For x equal to 0, y is equal to 0. This is how the graph is going to be. Y is equal to mod x. Why is we are able to get the feel, yes or no? Graphically, we are able to get the feel, correct? Graphically, now we know if the graph jumps, breaks at a point, that means at that point continuity is not maintained. Continuity is not there. So polynomial graphs never, it will never break. You know that. These graphs will never break. What about this one? Gent x, greatest integer function, right? Greatest integer function will break at every integer, right? Will break at every integer. If you remember the graphs, it is somewhat like this. This is not black. This the boldness is more. That's why this is open, right? It is like this, correct? It is breaking at every integer. It will break. It is continuous. These two graphs, fractional part and greatest integer function part, fractional function and greatest integer function. These graphs will only break when x is an integer. Rest everywhere they'll be continuous. This is only written. You must be thinking, sir, this is not continuous. This is not continuous whenever x is an integer. For rest of the parts, it is continuous. No problem in that. Correct? For rest of the part, it is continuous. Only at x being an integer, it is breaking. So there it is not continuous. Tan. Where will it not be continuous? On an odd multiple of pi by 2. At an odd multiple of pi by 2, this will be not continuous. Whenever your x is an odd multiple of pi by 2, there the graph will not be continuous. Rest everywhere, it will be continuous. Right? Remember tan's graph? It will break at every odd multiple of pi by 2. Okay. So by graph, now we'll be able to understand what continuity means. Continuity at a point, you have to check whether at that point my left hand limit, right hand limit and the value of function is equal or not. When will it be equal? When your graph is not breaking at that point, it's not jumping or breaking at that point. There is a value of function at that point and that value is equal to its LHL as well as RHL. This much only. This was only written over here, right? This thing only was written. Left hand limit, that means at a minus limit x tending to a minus, limit x tending to a plus for f of x, all of both of these are equal to value of function at a, that means f of a. This simple. Okay. Graphically, I hope we are clear. Now let's see some questions. How will we apply this in the questions? Because that's obviously they're not going to ask you. They might include just a minute. They might include graphs, graphical questions somewhere, but They'll not directly ask you that, okay, by looking at the graph, tell me if function is continuous at x is equal to a or not. They're not going to do that. I suppose not. Although sometimes JEE Mains gives really easy questions, but that's your luck if you get that in your set of paper. Now, what is written? Discuss continuity of function. Discuss continuity of f of x. Always they'll ask continuity where? Continuity at x is equal to 0 and x equal to 1. They are asking you to check the continuity at x is equal to 0 and x is equal to 1. How do we check the continuity? What have we learned? Right? We have learned that to check the continuity, we'll check left hand limit at x is equal to 0. Okay, to check the continuity at x is equal to 0, we'll check the left hand limit, right hand limit at x is equal to 0 and f of 0. All these three we have to see. So now, left hand limit, that means value of function when we tend to, right hand limit, value of function when x is slightly greater than 0. That means we are tending towards 0 from the right hand side, right? Value of function when x is slightly greater than 0. What is the value over here? When x is less than 0, value is x square plus 2. When x is between 0 and 1, the value is 3x plus 2. Between 0 and means slightly greater than 0 will fall in this part. Right? So left hand, I don't need to write the entire limit thing, no? Right? This thing, by RHL I mean x tending to 0 plus. 0 plus means from right side. Right? Function f of x will become 3x plus 2. This will be your f of x. This will become your f of x. If you are finding limit for the function, what will be the function when x is between 0 and 1 or it is 0? At 0 also this is the value. Between 0 and 1 also this is the value. So this is what you will be finding. RHL means this thing only. RHL means this thing only. That means RHL will be nothing but 3 into 0 plus 2. That means 2. What will be LHL? LHL would just mean limit of the function when x is tending to 0 minus. That means it's approaching towards 0 from the left hand side. Slightly smaller than 0. Slightly smaller than 0. What will be the value of function when x is slightly smaller than 0? Smaller than 0 means x square plus 2. So instead of writing this, I'll just write x square plus 2. What will be the value? 0 plus 2. So it is also 2. LHL is equal to RHL. Okay, now what about value of function at 0? When x is equal to 0, same value we are getting. When x is equal to 0, value will be 3 into 0 plus 2. When x is equal to 0, value will be 3 into 0 plus 2. Value of function when x is equal to 0 will be equal to, because right, this 3x plus 2. 3x plus 2 means 3 into 0 plus 2. So this is also 2. So function, that means f of x is continuous at x equal 0. Can we say that? Yes, we can say that without any doubt. Can we say that? Yes, we can say that without any doubt, because LHL is equal to RHL is equal to the value of function at that particular point. Now, what about x equal to 1? So we'll check LHL at x equal to 1. We'll check RHL at x equal to 1. We'll check value of function for 1 at 1. Right? What will be LHL when x is approaching 1 from the left side? That means slightly smaller than 1. Slightly smaller than 1 means it will fall in this interval. Slightly smaller than 1 means it will fall in this interval, and the value of function will become 3x plus 2. 3x plus 2, that means 3 into 1. We are checking for 1. So 3 into 1 plus 2, that means 5. What will be left hand limit at x is equal to 1? It will be equal to 5. What will be right hand limit at x equal to 1? Right hand limit means approaching 1 from the right side. That means slightly greater than 1. Slightly greater than 1. That means this. Equal or greater means 3 e to the power x plus 2. That means value of function will become 3 into e to the power x plus minus 2. Minus 2. Now we are checking limit at 1. So instead of x, we'll put 1. What will we get? We'll get 3e minus 2. Here itself we can say, right? Here itself we can say that it is not continuous because LHL and RHL are not equal to one another. Do we actually need to check the value of function at 1? At 1 also it will be 3e minus 2. But LHL and RHL itself are not equal. That means we are sure that it is not continuous at x equal to 1. F of x is not continuous at x equal to 1. Do I need to actually check f of 1? No, I don't need to. It is not continuous at x equal to 1. Simple to say that. As simple as that. Okay. At x is equal to 1, we can also not continuous or discontinuous, right? At x is equal to 0, it is continuous. At x equal to 0, it is continuous. Okay. Not for all questions, but for most of them, solutions will be there and notes will be uploaded. So don't worry about it. I hope AOD notes are also uploaded now. I've said that to the team. The last sessions, few students were asking about it. Now, see, in continuity, if they want to complicate a question, they'll do two things, right? They'll do two things. They'll complicate if they want the question, because concept is not complicated. Concept is same only. Concept is same only throughout. That left hand limit equal to right hand limit equal to function's value at that particular point. All three are equal. That means continuous. Otherwise, it's not continuous at that point. This definition only, this concept only. How will they manipulate it? They'll make limits difficult. They'll make it difficult for you to find the left hand limit and right hand limit. That means LHL and RHL itself you'll be struggling to find. Then how will you say whether it is continuous at that point or not? So first things first, that limit should be revised. Although here I'll be telling while teaching also, I'll be telling you the standard formats. Don't worry about it. Don't just go right now itself. No, first limits, then we'll come back to this. If you're here, then stay here. I'll try to revise, right? I'll try to make you revise. If you have studied limits even for the one time, then you'll be able to remember. So here you can see that these concepts are going to be used. What are the question? What is the question asking? Question is asking, function is given to you in all, obviously always function will be like this only, split it in parts, right? In parts only, function will be like this. Very rarely you'll see simple function. Okay, and they'll ask you to check the continuity at some point at x is equal to 0. They are asking over here. So function's value at x is equal to 0 is given to us as 3/2. Constant value is given to us. But the job, the question, the task over here is to find the function's value, is to find left hand limit and right hand limit. Hi Vijay, how are you? Hi Arhan. All good? Having fun? Okay. So at x is equal to 0, if you want to check, we'll check LHL, we'll check RHL, and we'll check f of 0. LHL, left hand limit at x equals 0. Or yeah, I'll write complete thing. At LHL means approaching towards 0 from the left hand side. Approaching towards 0 from the left hand side. So if we approach towards 0 from the left hand side, that means slightly smaller than 0, slightly smaller than 0, that means function will be this. When x is slightly smaller than 0, this will be the function. That means what we'll be checking? We'll be checking x tending to 0 minus. 0 minus means approaching towards 0 from the left hand side. For the function, now when x is less than 0, function is sine 3x upon tan 2x, right? This is your function, sine 3x upon tan 2x. Now if you remember in limits, limit for sines of 0 divided by same 0 is always equal to 1, right? This not this one, right? This is always equal to 1, standard format. Remember this. So sine of 0 divided by same 0 is always going to be equal. Now for making this format over here, what we'll have to do, we'll have to, this part will be divided by 3x. So multiplied with 3x, this part will be divided by 2x and multiplied with 2x. I'll write an extra step so that right? So sine 3x will divide by 3x, and tan 2x. The same is for tan also. So if we have divided 3x, we'll multiply 3x. If we have divided dx, we'll multiply 2x. Right? For tan, same thing for tan also is correct. If you have studied standard formats, then this is correct for tan also. Right? So this will become 3 by 2. Right? This will become 1. This will become 1. 3x by 2x will become 3 by 2. So this LHL is becoming nothing but 3 by 2. LHS also is coming equal to 3 by 2. RHL, right hand limit at x equal to 0. Limit x tending to 0 plus. 0 plus means slightly greater than 0. Very good, Vijay. Continuous. Correct. You're correct. You're correct. Definitely correct. Slightly greater than 0. Slightly greater than 0 means this one. That means log of function is now log of 1 plus 3x divided by e to the power 2x minus 1. Standard format, log of 1 plus 0 divided by same 0. Right? So here we'll divide 1 plus 3x is there. So we'll divide by 3x. So we'll multiply by 3x. Correct? We'll divide by 3x and multiply by 3x. This thing will become 1. Same format, e to the power 0 minus 1 divided by same 0 is equal to 1. Remember limits, this concept we have studied in limits part very easily, right? So e to the power 0 minus 1 divided by same 0 is equal to 1, same 0. So e to the power 2x is there. So what we'll have to divide with? We'll have to divide with 2x. Then here we'll have to multiply with 2x. So here also we'll get 2x. Again xx will get cancelled. What we'll get? We'll get 3 by 2. So my left hand limit and right hand limit are equal to 3 by 2 at x equal to 0, and value of function at 0 is already known to me. When x is equal to 0, the function is equal to 3 by 2. So LHL at x is equal to 0 is equal to RHL at x is equal to 0 is equal to function's value at 0 are equal. That means it is continuous at x equals 0. Simply. Okay, this is the concept. So you can see the question cannot be complicated too much. They can only play with limits, right? They can only complicate the limits part. Here they have done with h and minus h. No need to do that. You like if you have studied limits, you know the standard formats. You can do directly. You have to solve your limits faster. Okay, not every time you have to do plus h minus h. You should know where to put what. And L'Hopital also, you know. L'Hopital's application also here only, like in continuity only, where you can use L'Hopital, I'll also tell that. Okay, if I forget, remind me. Now, next thing which I was saying, one thing, they can include limits and make the question difficult. If they want to make it more complicated, they'll include greatest integer function or fractional part function. Okay. Greatest integer function is not a difficult thing, not a complicated thing. You know how to, you must have studied this in class 11 itself in very starting, right? In functions also you must have studied that once again. So greatest integer function, if you don't know, revise that for once, right? You can pause and revise what is greatest integer function. Although I am supposing that all of you know about greatest integer function, so there is no worry, right? They can complicate your question with this also. Sometimes with using greatest integer function, they might complicate your question. So you see that here GINT is being used. GINT or GIF, whatever you want to call it. GIF sounds better, right? Okay. Now, what is given? F of x is greatest integer function of x square minus 1 upon x square minus 1 when x square is not equal to 1. Okay, and function is 0 whenever x square is equal to 1. Whenever x square is equal to 1 means that your x is equal to plus or minus 1. Correct? Whenever your x is equal to plus or minus 1, the function's value will become 0. F of x will become 0. Whenever it is not equal to plus or minus 1, not equal to plus or minus 1, then your function's value will be this. And we are supposed to check the continuity at, this is at x equal to 1. We are supposed to check the continuity at x equal to 1. Okay. So now you see left hand limit, right hand limit will be same at x equal to 1. No? Should we check? Okay, we'll check. Not same, not necessarily same. All right, we'll check. We'll check how they will be. What do you think? Just give it a thought. Do you need to check LHL and RHL? Yes, I think yes, you need to check LHL and RHL. Directly you cannot say that LHL, RHL both will be equal because it's not equal to 1. Plus minus 1 it is. Okay, so you'll have to check LHL and RHL. For example, if we see RHL at x equal 1, right? RHL means limit when x is tending to 1 plus. 1 plus, that means slightly greater than 0, not equal to 1. Not equal to 1, right? Slightly greater than 0, slightly greater than 1 means not equal to 1. Not equal to 1 means function will be this thing. Right? That means it will be greatest integer function of x square minus 1 divided by x square minus 1. Okay. Now x is slightly greater than 1. What will this become? Slightly greater than 1 means 1 plus 1 point something square will tend to 1 only. 1 minus 1 will become 0. So what are we getting in the numerator? We are getting 0. And what will this be? This will be tending to 0. This will not be 0. 1 plus, that means square of 1 point something. This will be tending to 0, not exactly 0. Tending to 0. Correct? 0 divided by tending to 0, that means this limit is going to come to 0. This limit is going to be equal to 0. RHL is equal to 0. Now if we talk about LHL at x equal to 1. LHL at x equal to 1 mathematically would mean x tending to 1 minus slightly smaller than 1. Again, it is not equal to 1. That means function's value is not equal to 0. That means just a minute. That means value will be this thing only again. But will the value change? Let's see. X square minus 1 divided by x square minus 1. Greatest integer of x square minus 1 divided by x square minus 1. Now your x is slightly smaller than 0, smaller than 1. Slightly smaller than 1 means 0.9999 something. Correct? Its square will also be 0.9999 something. Correct? Square will also be slightly smaller than 1. Slightly smaller than 1. When we'll apply greatest integer function on 0 point something value, this greatest integer function will make it 0. That means in the numerator we'll have 0 minus 1. Correct? Exact 0 minus 1. This will be exact 0. Smaller than 1. 0 point something. 0.9999. Right? Square will also be 0.9999 something only. Right? But greatest integer function will make it exactly 0. 0 minus 1 is going to give us minus 1. Now do you see that LHL and RHL are going to be equal? It was important to check over here. We cannot directly say. Like I was saying that sometimes you might see just look that not equal to 1 value and equal to 1 value, another value. That means you cannot directly say that okay, RHL LHL will be equal. No, you have to check here. You can see they are different, right? And denominator again slightly smaller than 0, that means 0 square 0.999 something minus 1, that means tending to 0. This will be also tending to 0. Again, this will tend to 0 only. Minus 1 divided by something which is tending to 0, that means it will give you infinity. Denominator is tending to 0, numerator is minus 1. It is going to tend to infinity. Tending to infinity or infinity, directly we can say because there is limit. So we can say directly infinity only. So LHL at x equal to 1 is not equal to RHL at x equal to 1. So do we need to, now we don't need to check function's value at 1, although it is given equal to 0, but LHL and RHL itself are not equal, no? So not continuous at x equal 1. It is not, definitely not continuous at x equals 1. Right? LHL is not defined or say infinity and RHL is coming 0. That means they are not equal. Function's value at 1 is equal to 1. Okay, so not continuous. Okay, let's move ahead. Now see, directly we can do multiple correct or multiple choice. Multiple choice anyway it is multiple. I think multiple correct it should be. Uh, it should be multiple correct. Okay. Now question from advance based on this particular concept. Now you see that they cannot complicate the question very much. They are only going to play or manipulate you using limits, not anything else. They can only involve limits, and that's going to bother you. Otherwise, the concept is very simple. Okay, what is the question saying? Let greatest integer function less than equals to x, then on which of the following points this is discontinuous. Discontinuous. That means RHL, LHL are not equal, or they are not equal to f of a. That's what it is saying. Now, before this, before talking about this, I'd say we remember this trigonometry concept, right? Cos of n pi plus theta. If your n is even, right, then this will become cos theta. Remember, right? If n is even, then cos of n pi plus theta will be cos theta. And if n is odd, then it will become negative of cos theta. Just this concept is going to be required in this question. Right? Cos of n pi plus theta is cos theta only if n is even. If n is odd, right, cos of 2 pi plus theta, first quadrant, positive only, right? Cos of pi plus theta, what is this? Third quadrant, negative. So for n pi plus theta, when n is odd, the value will be negative cos theta. When n is even, the value will be cos theta, positive cos theta. This is what we are going to require over here. Now, looking at the question, I hope you have directly understood. If you are well versed with your trigonometry as well as till now what we have understood about continuity, you can easily solve it. Not continuous. Okay, you can easily solve it. What is this written over here? If you see, what is this? Let me write the function. Your function f of x is nothing but x cos of pi x plus pi into greatest integer function of x. Greatest integer function of x. Sir, why did you use n pi plus theta? We are still not getting it. We'll get it. Wait, let's reverse it over here. Can I simply write it instead of this? Can I write greatest integer function of x into pi plus pi into greatest integer? Oh, sorry, plus pi into x. Plus pi into x. Hey, what happened? Hey? What all happens here? Okay, right. Now, did you get why am I saying n pi plus theta? Wait, greatest integer function, that means this is always going to be an integer, right? Whatever is the value of x, this thing is always going to be an integer, yes or no? This particular thing is an integer. Whatever is the value of x, we'll get an integer over here, yes or no? Yes, we'll get an integer without any doubt. So isn't this part cos of n pi plus theta? This part, I'm talking about this part. This part is nothing but cos of n pi plus theta. N is an integer. This pi x becomes theta. Correct? This is n pi plus theta. Greatest integer of x is your integer now, n pi now. So this is nothing written. This only is the trick in this entire question. This is why this is advanced question. Otherwise, it's a normal question of continuity. Here you have to just understand that this thing what's written over here is cos of n pi plus theta. Okay. So this is nothing but x into cos of n pi plus pi x. So now what will be the value? What will be the function? This function is nothing. Now we'll have to split it according to the even and oddness of your gent of x. Okay, so now this function, what will this become? When your mod x, sorry, not mod x, when your greatest integer x is even, whenever this will be even, whenever this will be even, your function, what will it become? N pi plus theta, n is even. That means function will be cos theta. So x multiplied with cos theta, that means x cos theta. Theta is pi x, so x cos pi x. Whenever your greatest integer function of x is odd, whenever this thing comes out to be odd, this will become cos of n pi plus theta, where n is odd. That means the value will be negative cos of theta. That means negative x cos pi x. That's it. Now they are asking you to check whether the function is continuous, where the function is discontinuous, where at which values of x the function is discontinuous. Let's say we are checking at x is equal to 0. How will we check? We know how to check, right? We know how to check at x is equal to 0. LHL at x is equal to 0. LHL at x is equal to 0. LHL means left hand limit, like that means slightly smaller than 0. Slightly smaller than 0. What will gent of x become? Greatest integer function of x will become when x is slightly smaller than 0. That means 0.9999 something. So this greatest integer function will make it 0. 0 is even. You know that, right? 0 is even. So it will become, what will it become? 0 is our even, no? What by LHL, what do we mean? Let me write the complete thing. Limit x tending to 0 minus. X tending to 0 minus, what will be the value of function when x is tending to 0 minus? 0 minus means x greatest integer function will make it 0. 0 is even, so function will be x cos x, x cos pi x. Whatever this cos pi x is, you don't need to bother about it. Your x is 0 over here, you have to take x as 0, right? It will be tending to 0, so this thing will be 0. Correct? Limit, right hand limit, if we check x tending to 0 plus, 0 plus means slightly greater than 0. I'm sorry. Wait. One mistake we have done. I take my words back. Yeah, sorry. My bad. When we are saying 0 minus, okay, that means slightly smaller than 1. Minus 1 point something. Right? Minus 1 point something. Correct? So this left hand limit, when we'll check for x slightly smaller than 0, that means minus 1 point something, slightly smaller than 0. Right? So greatest integer function will make it minus 1. I'm sorry, greatest integer function will make it odd. 1 means odd, slightly smaller than 0. 0 minus will be slightly smaller than 0. That means our greatest integer function will make it odd. 1 is odd. So that means your value over here will come as minus x cos pi x. Minus x cos pi x. Okay. It will become odd. It will become odd. Slightly smaller than 0. Slightly smaller than 0 won't be 0 point something. It minus 1 point something it is going to be. So it will be odd. It will tend to 1 and it will be odd and its value will be minus x cos pi x. Now this will become 0. This will also become 0. No problem, because x is tending to 0. So this entire thing will become 0. Now if we check the right hand limit, that means limit of x tending to 0 plus. This will give us 0. 0 plus means 0 point something. That means greatest integer function will make it 0. Right? So your this gent of x is 0 now. 0 means even means this value, that means x cos pi x. We'll apply the limit on x cos pi x. Here also, whatever this thing is, doesn't matter, this is 0. This x is 0, so entire value will come out to be 0 only. Right? And function's value at 0 is definitely going to be 0 because x is going to be 0. So now f of 0 is definitely going to be 0. So that means at 0, it is continuous. LHL, RHL and functions value at 0 is coming equal. All three are equal. That means it is continuous at x is equal to 0. That means this is not going to be my answer. It is asking about discontinuity. It is asking about discontinuity. Correct? At 0 it is continuous because left hand limit at 0, right hand limit at 0 and functions value at 0 all are coming equal to 0. Now from this example only try to deduce the other options, right? For example, this one, limit x tending to 1 minus 1 minus, what we'll get, we can do orally. Limit of the function when x is tending to 1 minus, when it will tend to 1 minus, what are we going to get? Odd, right? Odd. 1 minus means this will become odd, slightly smaller than 1, 0 point something. So sorry, yeah, 0 point something. So LHL will become even, 0 point something, slightly smaller than 1 means 0 point something. So gent of x will become 0. This will become 0, 0 means even. That means function's value is x cos pi x. Correct? Cos pi minus 1. Right? X is minus 1. Sorry, cos pi will become your, what will this value give you? It will be 0. Yes, Vijay. What will this give you? LHL will be equal to, LHL will come out to be equal to minus 1. It will become cos pi, cos of pi. Okay, that means minus 1. Now, right hand limit x tending to 1 plus, that means x, what will be the value? First, let's say 1 point something. Gent will become 1. Odd, 1 means odd. That means value will be minus x cos pi x. Right? Minus x cos pi x. Here we got minus 1. Why? Because cos pi is minus 1, x is 1. So 1 into minus 1, minus 1. But over here, minus into 1 into minus 1. That means plus 1 we are going to get. Got my point? Your LHL is minus 1. RHL is coming out to be plus 1. Okay, RHL is coming out to be plus 1. And functions value at 1, you don't need to check now because LHL, RHL itself are not equal. That means it is discontinuous at x equal to 1. This answer is correct. Now, same thing will happen at x is equal to 2 also. Same thing will happen at x is equal to 2 also. Plus and minus. LHL and RHL will be opposite of each other. Same thing will happen there also. So here also it will be discontinuous. Same at minus 1. RHL will come out to be equal to minus 1 and LHL will come out to be equal to plus 1. So same thing will happen at minus 1 also. So only at x is equal to 0 this function is continuous. Rest at all the integral values of x, it is going to be discontinuous. Sir, 1 minus k should be 0 now. Minus this one, Vijay, 1 minus this one. Cos pi is minus 1 na beta. Cos pi is 0. Acha, 1 minus k should be 0. 1 minus k should be, 1 minus will be 0.99 something. Greatest integer will make it 0. 0 is even. That means function's value will be x cos pi x. 1 plus means 1 point something, slightly greater than 1. So greatest integer function will be making it 1. Greatest integer function, this thing will be 1. 1 means odd. That means function's value will be this, minus x cos pi x. That's what I'm saying. 0 into something. Hey, here x is tending to 1, not 0. Here x was tending to 0. That's why we said 0 into something. Here x is tending to 1, not 0. If you're confused with that. Tell me quickly. GIF 0 something. GIF 0 something. 0 point something will be 0 here. Okay. 0 minus, that means slightly smaller than 0. This one you are saying? Yeah, GIF of 0 point something will be equal to 0. Pakka. That you are correct at. GIF of 0 point something will be 0. GIF of 1 point something will be 1. Correct. I hope I didn't confuse you guys anywhere. Okay. Or you can say function's value at 1 plus will not be equal to function's value at 1. That way also is step of 0 something is equal to 0 into minus 1 equal to 0. Step of 0 something equal to 0 into 1. This step you're talking about, I'm putting the finger. That is 0 minus or 0 plus, we are only LHL of minus, LHL of 1 minus. 1 minus, okay, this thing. LHL of 1 minus means x is tending to 1 minus means 0 point something, right? Slightly smaller than 1. That means 0 point something. So 0 point something. Gent will make it even. Gent will make it 0. 0 point something will become 0 and 0 is even now. So the function's value will become, what will be the function in case of whenever gent is even, the function is this. That's why this thing. So 1 into cos pi, 1 into minus 1 equal to minus 1. LHL, RHL of 1, that means 1 plus 1 point something. 1 point something gent will become, GIF will become 1 only. 1 is odd, that means function will this. Yeah, 0 is even. 0 is even. 0 is even. 0 is even. 0 is going to be considered as even. 0 is divisible by 2, right? Okay. Moving ahead. 0 is even to sahi to. 0 is even, that's why we took this value. No? When 1 is odd, that's why we took this value. Okay. Let's come to this. Again, a PYQ. Most of them are included are PYQs only, just a few different variety of PYQs will give you confidence or continuity. That's why PYQs only are included. Okay, let greatest integer function. Again, they have introduced greatest integer function. You see, anywhere they want to complicate the question, they'll include greatest integer function for sure. Okay, they'll include greatest integer function for sure. Wherever they want to complicate your question even a little bit. Now, this is your function limit. Now, what they have given, that greatest integer, this is greatest integer function definition only, nothing else. They are saying that this value, the value of this limit is equal to a, and these are your options. I think a, these are your options. They are saying that value of that this limit when x is tending to 0 is equal to a. Then you have to check. Then you have to say. Then the function. Then you have to know. Then you have to tell when this function is discontinuous. Then at that time, for that condition, what x should be. What x should be equal to. Again, I'll explain. They are saying value of this limit is equal to a. Putting a here is proved logical by looking at the options. Options are in terms of a. So first we have to find a. Okay, simple limit question only it is. Discontinuous, continuity is starting from here. Now they are saying this particular function is discontinuous when x is equal to what? Okay, and in this also again, you see greatest integer function is involved. Here also greatest integer function is involved. Greatest integer function, you see greatest integer function will only be discontinuous when your this thing is an integer, whatever is inside your function is an integer. At that point it will become discontinuous. Correct or not? Correct, right? At that point it is going to become discontinuous. Okay, now left hand limit. Limit x tend, what we have to yeah, limit x tending to 0, not left hand limit. First we have to find this, right? First we need to find this. Here x is multiplied, so x multiplied with 4 by x GIF. Okay, this is equal to a. Can I also write, you remember, right? GIF can be written as number minus its fractional part. Fractional part. This is how we use, this is how we write number minus its fractional part. Okay, number minus its fractional part. That is greatest integer. Okay, so now instead of writing this, I'll just write limit x tending to 0, x multiplied with 4 by x, x multiplied with 4 by x minus fractional part of 4 by x. Correct? No problem in this step. So this just becomes limit somewhere x tending to 0, x into 4 by x, that means 4 only, minus x into fractional part of 4 by x. Now here what was the problem? Why were we not able to find the limit? Directly we could cancel x and x, no? Limit could be equal to 4. No. At x equal to 0, this thing is becoming undefined. That is why we did not directly put x. That's why I said this first. Okay, why did I have to write this? Why did I not cancel x and x and say 4 should be the answer? Array, no, I cannot cancel x and x. I cannot even put value of x directly because it is making the function undefined. X is in denominator. Whenever this is the case, please explain fractional part. Fraction, just like in greatest integer function, for example, 1.34 we have. Suppose we have 1.34. The greatest integer of 1.34 will be only the integer part. That means 1. Fractional function means, fractional part means 0.34, 34 by 100. That's the fractional part. Okay. Last but not the least. Huh? Don't worry about it. Right? Keep understanding here only. Now, this part is clear. Why did I not cancel? That should also be clear because x was making it undefined. X is equal to 0 will make this thing undefined. So I had to break it into number minus its fractional part. Integer minus its fractional part. This is how I'm going to get. Now, this x I multiplied inside, I got this. Now 4 is okay with me, not a problem. Now I can put the limit, right? Why? Because see, this is getting undefined. This thing is getting undefined. Fractional part will be some value, not undefined. This is just the fractional part. This is now one entire value. It is not 4 by x. I'm not putting x over here. This is some entire value. This will have some value. Whatever value this will have, this x will become 0 because of this limit. X 0 multiplied with whatever this is. Whatever this is. Right? Some fractional part it is going to be. Right? It's not that now it's not undefined. Now it's not undefined. It will have some value. But whatever value it is going to have, this x multiplied with that value will make it 0. Will make it 0. So this thing, limit x tending to 0, no, don't have to write it. So this entire thing will just remain 4 only. Will just become 4. If you would have cancelled, yeah, if you would have cancelled here, then also answer would have come 4 only. I'm not saying that, right? No, answer would come 0 in that case, right? Here, if you put x as 0, answer would come not defined, but even if you miscalculate, it will come 0 only. But actual answer is equal to 4, right? By some fluke, if you cancel x and x, then only it can come equal to 4. But the real thing about that is this: x into that fractional value of 4 by x. Fractional, here x is tending to 0. You see, here x is tending to 0. It will have some fractional value. It will not be equal to 0. Right? Here x will be tending to 0. But 0 into this will make it 0. So answer will come out to be 4 only. So 4 is our A. A's value is equal to 4. First task in this question was to find the value of A. So A's value is coming out to be equal to 4. Now A is 4. That means this will become 24 plus 5 square root. That means 5. This will become square root of 4. That means 2. This will become 4 plus 1 square root of 5. This will become 5 plus 4, 9. Square root of 9 will become 3. 3, 2, 5 and root 5. These 4 options we have. These 4 options we have now. Right? After finding the value of A. Now next step is, this particular function is discontinuous when x is equal to what? That we have to answer. What is our function? Function is greatest integer function of x square, greatest integer of x square sine pi x. Now you tell me, here sine pi x will not bother you, right? Sine pi x is not going to bother you. Will it bother you? It will not bother you. Sine pi x is not going to bother you at all, right? Only thing we have to check over here is this particular thing. This particular thing. For example, if we check at x equal to 5, x equal to 5, right? This will become, now at x is equal to 5, RHL and LHL, what will they be? If you check about at x equal to 5, what will be your RHL and LHL? They'll be equal, right? Limit if we check at 5, 5 square 25, greatest integer function will be 25 only. This will become 0. This is going to become 0. LHL, RHL will be 0. Function's value at x is equal to 5 will also be 0. So when x is equal to 5, LHL, RHL and value of function will come equal. That means it will be continuous. That means this is not my answer. I want discontinuous. Getting my point? If I check at any integral value, right? At any integral value of x, if I'm checking at any integral value of x, this will jump. This GINT will jump. Definitely at integer it will jump. But this sine pi x will make it 0. Because x, whenever x is an integer, sine n pi will be 0. This entire thing will become 0. So LHL, RHL and value of function at any integer is going to come equal. Is going to come equal. LHL, RHL, you don't need to check only, because you know for sine n pi, LHL will also become 0, RHL will also become 0. Right? Whenever you'll put any integer instead of x, this will become sine n pi. It will make this entire thing 0. LHL, RHL and your function's value will come equal to 0. So at x is equal to 5, I'm not going to get any. At x is equal to 5, I'm going to get continuity. At x is equal to 2 also I'm going to get continuity, because LHL, RHL and value of function, all three will be equal to 0. At x is equal to 3 also I'm going to get continuity. Only at non-integral value of x, I'll get discontinuity. Only at non-integral value of x, I'm going to get discontinuity, because there this thing will not become 0 and this will make it jump. This thing will not be equal to 0 in that case. Get my point? At x is equal to root 5, the function will be discontinuous. This function will become discontinuous. RHL, LHL and function's value will come differently. At all integral values, when we put x is equal to 5 here, this thing will make entire function 0. So RHL, LHL will also come out to be 0 only. Okay. If we check in the neighborhood of 5, this LHL will come out to be 0, RHL will come out to be 0, function's value will come out to be 0. All will be equal. That means that is continuous at x is equal to 5. At 3 and 2 also will be the same thing. Only when x is non-integral, this will happen. Very important concept we are learning over here. We know that greatest integer function will jump or will break on integers. But here we have sine n pi. This, whatever, how much ever it wants to jump, this will calm it down. This will make it 0. This will make it 0. This function will only be able to jump when this is not able to make this as 0. This is not able to make the entire function as 0. Got my point? Are we understood? Everybody? Vijay, are we clear? Okay. Now, same type of question came in 2021 also. Whatever we solved just now, same concept we are going to use. Same concept, or every time they'll use similar type of things. Something to play with greatest integer. Something they'll involve to play with greatest integer. Hi Said Roshan, how are you? All good? Having fun? F of r belonging to, for all r defined as f of x is equal to this, where this is greatest integer function, then f is options. Options are, I don't know why, how did I miss this? A, B, C, D. Okay, 4 options we have. Now what is my function? Look at the function again carefully. If you are thorough with greatest integer function, you'll be able to do these questions very easily. Right? X minus 1 cos of 2x minus 1 by 2. Look at this function now. Now see, no need to go at LHL, RHL and all the things. You will automatically, your mind will recollect that when, what will happen. Now see, this particular thing, instead of writing this, okay, there is pi also. There is pi. So can I write, instead of this, can I write greatest integer function of x minus 1 cos of 2x minus 1 into pi by 2. This makes more sense. Why this makes more sense? Because we know that at an odd multiple of pi by 2, cos becomes 0. We know at odd multiple of pi by 2, this thing will become 0. No problem, Said. Okay, try to understand, try to figure out what I'm saying. Try to apply the last questions approach again over here. I'll just drink water and come back. Give me a minute. Read the question once on your own. Try to do it. Stay in the session. Depending on 2x minus 1. Correct, Vijay. Great. So by looking at the function, leave limit. By looking at the function, can you understand? This greatest integer function only is going to bother us. This we can handle. We know that at odd multiple of pi by 2, cos will become 0. Correct? This is going to bother us. Now, when is this going to bother us? Whenever this particular thing will be an integer. Whenever this gent will be an integer, that time our graph will jump. Yes or no? Suppose your function is greatest integer function of x. You know that this graph, this function is going to take jumps, or this function is going to break whenever this thing comes out to be an integer. But if you suppose, if we have a limit over here, if you multiply it with something which is 0, if you multiply with it with something which is getting 0, which is becoming 0, then RHL and LHL will not be affected. Both will come out to be 0. My point is that your function, when you'll find the limit of this function left LHL and RHL, it will change. It will be different if only gent of x was there. Right? Only gent of x was there. It will change if your gent, if this thing is coming out to be integer, then your LHL and RHL will be affected only if only greatest integer function is there. If you have something which is becoming 0 multiplied to this greatest integer function, then LHL and RHL will not change, right? Then continuity will not be affected. Do you believe? Correct? If your function is only gent of x, GIF of x, then yes, you can say that LHL, RHL will be affected and the continuity will break, the graph will jump. But if same 0 is multiplied with this with this particular function, if we have x multiplied where x is tending to 0, now LHL and RHL will not be affected because both will become 0. They'll not be affected. Same thing is happening over here. Now I know what are they asking? They're asking discontinuous, continuous, continuous, discontinuous. I know that this graph is going to be continuous everywhere, but it will be discontinuous whenever, because this thing is not going to affect my continuity. Only this is affecting my continuity. And whenever, I'll write it down over here. This f, just note, f of x will be discontinuous when this thing is an integer. Whenever this is an integer, this answer leads to be an integer. Correct? Whenever your inner value is an integer, not the entire thing. Whenever your x minus 1 is an integer, then only the function will be discontinuous. When this part becomes your integer, that means only at that point your function will become discontinuous, because RHL and LHL will be different and continuity will break. Correct? Believe me. Over here. What is happening here? Just a second. Okay. Now, now see, it will be discontinuous whenever x minus 1 is giving you an integer. And if x minus 1 is an integer, that means x is also an integer. Whenever your x minus 1 is integer, your x will also be an integer. Whenever x minus 1 will be an integer, x will also be an integer. If x will be an integer, then this 2x minus 1 will also be an integer. Like if x is an integer, that means 2x minus 1 into pi by 2 will be an odd multiple of pi by 2. If x is an integer, this integer you'll put over here, you'll get odd multiple of pi by 2. This thing will become 0. So when this part will try to become integer, whenever this part will be becoming 0, this part will also become an odd multiple of pi by 2 and it will make the entire function 0. So basically, continuity is never going to break. It will always be continuous. Again, I'll repeat. I'll say that you want to check the continuity of this thing. You know this part is not going to bother you. Only this part will bother you. When will it bother you? Whenever this will become an integer. Whenever you'll have an integer inside, that time it will bother you. Because 4, suppose you want to check it 4. 4 is an integer. 4 point something. Greatest integer will make it 4. And 3.99. Greatest integer will make it 3. So LHL and RHL will come out to be different. Only that time. But you see, whenever this thing is coming as an integer, this is also going to give you an odd multiple of pi by 2. This odd multiple of pi by 2 at cos into cos of odd multiple of pi by 2 will always become 0. So whenever this is, even if it is becoming integer, to try to create the discontinuity, this part is making the entire function 0. So LHL, RHL will not be effective. So continuity will never break. It will always be continuous for every real x. Whenever it is not an integer, continuity is maintained. You know, gent will be continuous whenever gent of x will be continuous when x is not an integer. It will be non-continuous at the integer points. Whenever x comes out to be an integer, continuity will break. Correct? So whenever continuity is breaking, this is making it zero. This particular thing is making it again continuous. This is maintaining the continuity. It's very important to understand this concept over here. Okay. So this was one variety when they'll ask you to check the continuity. We need to check the continuity, or checking the continuity at which point it will be continuous, at which point it will be not continuous, that we were checking. Now next type of questions which we get is that they'll tell us that the function is continuous, right? And they'll ask the values of some constants. This is okay, this is last part only, right? See, here also they have the same thing. So if x is if your x is an integer, then this will also become an odd multiple of pi by 2. So it will become n minus 2. X is n, x is integer. This, whenever it will become an integer, this part will make the entire thing 0. So this cannot break the continuity. This will always be, forever be continuous. At non-integers, it is continuous. It is anyway continuous. And whenever it is coming out to be integer, whenever x is coming out to be an integer, this part is making it 0. LHL, RHL and functions value, all the three will be equal to 0. So it will maintain the continuity. Okay. Now next type of question which I was talking about. Next type of question. Now they'll say that it is continuous. If it is continuous, then tell us the values of some constants or some they'll ask something depending on that. They'll ask something depending on that. Here also same concept is not changing. Variety change, but concept will not change. If it is continuous at x is equal to 1, we know LHL. Achha, pink color. If it is continuous at x is equal to 1, we know LHL at 1 will be equal to RHL at 1 will be equal to value of function at 1. This we know already. This only we need to apply. Nothing much. So left hand limit at 1. Whenever x is slightly smaller than 1, left hand limit means whenever x is slightly smaller than 1. Whenever your x is slightly smaller than 1, what will be your limit? It will be 5 into a into 1 minus 2b. So 5a minus 2b. Write the complete thing. So LHL would mean limit x tending to 1 minus. When x is tending to 1 minus, that means it's smaller than 1. That time your function will be 5ax minus 2b. This will be your function. Correct? And what will be the limits value? So we'll put x equal to 1 over here and it will become 5a minus 2b. What will be RHL? Limit of x tending to 1 plus. 1 plus means slightly greater than 1. That means function will be this one. It will be 3ax plus b. Limits value will be 3 into 1, 3 into a into 1 plus b. That means 3a plus b. These two are equal to function's value at x is equal to 1. F of 1 is given to you as 11. So basically you have to just solve the linear equations where your 5a minus 2b is equal to 11. All these three are equal, right? LHL equal to RHL equal to f of 1. All these three are equal. Okay. So your 5a minus 2b will be equal to 1 and 3a plus b will be equal to 11 and your 3a plus b will also be equal to 11. Just solve the equations. I think Vijay has solved 2 and 3. A equal to 2 and b equal to 3, or a equal to 3, b equal to 2. I think a equal to 3, 5, 3, 2, 15 minus 4. Yeah, a equal to 3, b equal to 2 should be correct. Right? A equal to 3, b equal to 2 would be correct. A equal to 3, b equal to 2, right? Okay. Right, so same concept we are applying here also. If they have given continuous, you just apply LHL equal to RHL equal to functions value at that particular Okay. Now again, here also in this type of question also, if they want to bother you, they'll bother you with limits only. They'll give horrible functions and that's it. You just need to know the standard formats of limits, nothing else. For example, here, if you see, you might not be able to see it very clearly. I think it's very small. I'll write. Okay, I'll write. Again, here also, but the concept will be LHL. What do you need? What are you supposed to write? It is continuous at x is equal to 0. The function is given to be continuous at x equal to 0. It is given to us, right? Then we have to find the value of 6a plus b square. This is the second variety of question. I told you in the starting, right? Only two variety of questions can be there, right? And one concept. So here also concept is same. Variety has changed. LHL at 0 should be equal to RHL at 0 should be equal to function's value at 0. Function's value at 0 is given equal to b. LHL, RHL will be able to find. LHL means left hand limit. Whenever function is limit of x, whenever your function is tending to 0 from the left side, that means 0 minus. In this case, what will be the function? If your x is less than 0, function will be this. 1 plus mod of sine x to the whole power 3a by mod of sine x. It is 1 plus mod of to the whole power of 3a by mod of sine x. That's it. This is written. Okay, this will be your function. Equal to right hand limit, that means limit x tending to 0 plus when x is slightly greater than 0, that means this value, e to the power cot 4x by cot 2x, e to the power of cot 4x by cot of 2x. This will be your function now. Should be equal to f of 0. F of 0 is given to you equal to b, although, but let's write f of 0 only. Although this f of 0 is given to you equal to b. So these two should be equal to b. That's what we need to, that's what we have. That's what we need to use for finding our answer. Now it's all about limits. What is this written? 1 plus 0 to the power infinity. Right? 1 plus 0 to the power infinity. What is this is the standard format. What is the limit? Limit will come out to be, this will become e to the power limit x tending to 0 1 plus 0 1 plus f of x to the power infinity, or 1 plus f of x to the power g of x, where g of x is tending to infinity. That you can say. Which part, Avinash? Your g of x is tending to infinity, no? Correct? If you put this as 0, this will tend to infinity. This is 1 plus f of x to the power g of x. Avinash Pro 2. 2 what? Second step, this thing. Which part? Okay, which part? Okay. Standard format. 1 plus f of x to the power g of x, where g of x is tending to infinity. So now power limit of x tending to 0, f of x into g of x. F of x is your sin x, mod sin x, and g of x is 3a by mod sin x. Only this concept, if you forgot this concept, then only this question can bother you. Otherwise, it will not bother you. Simple. 1 plus f of x to the power g of x, where g of x is tending to infinity. And it is tending to infinity because this is tending to 0. Right? So in that case, the result of this limit will be e to the power limit x tending to 0, f of x into g of x. F of x is your sin x. This entire thing is not f of x. 1 plus f of x. Okay. Right. Will be equal to limit. Now this part. Finding the limit over here. E to the power of cot 4x by cot 2x. Cot 4x by cot 2x. This is also standard format. Cot 4x by cot 2x. Can I write it as tan 2x by tan 4x? Right? This thing can be written as tan 2x by tan 4x. Tan of 0 by same 0 is 1. So this divided by 2x into 2x we'll do. This divided by 4x into 4x we'll do. This will become 1 standard format. This will become 1 tan of 0 by same 0 and sine of 0 by same 0. Limit to those will always be equal to 1. So this is 1, this is 1. 2x by 4x. 2x by 4x will become 1 by 2. This will become 2 by 4. 2x by 4x will become 2 by 4. That means finally we'll have e to the power of 2 by 4. So 1 by 2. This will become e to the power of 2 by 4. Yeah, e to the power 1 by 2. I'll write 2 by 4 and 1 by 2. I'll write in next step. No problem. This is equal to b. What did we get from here? We got e to the power 3a equal to e to the power of 1 by 2 equal to b. From here, from these two, using these two, what are we getting? 3a equal to 1 by 2. That means a equal to 1 by 6. A equal to 1 by 6 and b is equal to e to the power 1 by 2 already. Right? So what are we supposed to find? We are supposed to find 6a plus b square. 6a plus b square. Okay. So 6a plus b square means 6 into 1 by 6. That means a only. Sorry. 1 only. 6 into 1 by 6, 1. B square. That means e to the power half square. E to the power half square. That means e only. So final answer I'll get is, we don't have that in the options. We have 1 plus e. Final answer which I'll get is 1 plus e. Okay, limit standard formats of limits only are used over here. Nothing much. The concept of continuity was very little, which we can anyway apply. It's only about how well are we able to solve the limits. Okay, this was standard format, 1 plus f of x to the power of g of x. Here also standard format, tan of 0 by same 0 or sine of 0 by same 0, e to the power x minus 1 upon x. These are standard formats, so those you'll need to revise. Okay, let's try to do this one. Read it. Same, you are well versed with the concept now. Try to use the concept. Okay, even if you're watching the recording or you're watching live, think about this question for 20-30 seconds. Think what you are supposed to do. That's it. Solving and all you'll be able to do, but first think what you're supposed to do. By now we should be well thorough about thinking what we are supposed to do. Come on. The function is defined only between minus 1 by 3 and 1 by 3. Okay. It is continuous, then k is equal to what? Now see, function is continuous. Continuous at obviously x equal to 0. They are talking about continuity at x is equal to 0. These values they have given related to x equal to 0. They are talking about continuity at x is equal to 0 and this function is continuous. Then what is k? K is the value of function when x is equal to 0. Now, whenever x is not equal to 0, that means LHL and RHL in both the cases, be it LHL or be it RHL, greater than 0, smaller than 0, right? Be it LHL or RHL, both will be equal to this only, 1 by x log of this base e. Correct? So basically, no need to check for RHL and RHL and LHL, both will be equal to one another. Whenever x is not equal to 0, this will be the function. Okay, this will be the function. So limit of x tending to 0 will check, x tending to 0 only will check, right? And limit of x tending to 0 for 1 by x log of 1 plus 3x by 1 minus 2x base e. Or instead of log we can write ln also, right? Natural log only this is. Now again, concept of limits. This should be equal to value of function at 0. Value of function when x is equal to 0. Right? LHL, RHL both will come out to be equal over here, like this only. Same only. K equal to 5. Correct, Roshan. Correct. Amazing. Very good. Both LHL and RHL will come out to be same only, and both LHL and RHL should be equal to your function's value at 0. So in this case now, whenever x is not equal to 0, this is the function. This is your function. And this will be same. So LHL, RHL, same thing only we are getting. Now limit. This limit we have to find. This limit we are supposed to find. So limit of x tending to 0. Now 1 by, see, ln of 1 plus 3x upon 1 minus 2x. We can break it, ln of 1 plus 3x minus ln of 1 minus 2x. Correct? So what I can write, 1 by x into, sorry, 1 plus 3x by x, or instead of this, just write it like this, ln of 1 plus 3x by x, right? This x minus ln of 1 minus 2x by x. Correct? Now, standard format again, 1 plus 0 by same 0. So same 0 is not there. So what we'll do, we'll divide by 3, multiply with 3. Here, minus 2 should be there. 1 plus 0 by same 0. So minus 2 will be multiplied. Minus 2 will be multiplied over here. This will become plus, and we'll have a 2 over here. Correct? This is going to become 1. This is going to become 1. What will remain? What will remain? Only 3 plus 2, which will be equal to your k. So k will come out to be equal to, correct, correct side, Roshan. Very good. This will come out to be equal to 5. Okay. Now here one more thing, that what they can ask the same question in one more way. What they'll say, they'll give you f of x is equal to this function. They'll give you f of x is equal to this function. Right? For x being not equal to 0, they'll tell that f of x is this for x not equal to 0. And if it is continuous at x is equal to 0, then what should be f of 0? They'll ask you what should be f of 0. If they'll say that f of x, they'll give you this function only, f of x is equal to only this when x is not equal to 0. They'll only give you this part, f of x is equal to this part when x is not equal to 0. And they'll also say f of x is continuous at x is equal to 0, and then ask you what is the value of f of 0. They can also ask you this way. In that case also same thing you'll have to apply. If it is continuous at f of 0, then limit of its limit will be equal to f of 0. Its limit at x tending to 0 will be equal to f of 0. Okay, will be equal to f of 0. This also can be the way they can ask you the same question. This question only we did now, just now. Same has repeated. Okay. So two varieties, single concept. Greatest integration function should be thorough, right? Limit standard format should be thorough. You are good to go with continuity. There is no problem in it at all. Be it advanced or mains, you're good to go with the questions. You can attempt the questions if you're able to understand the limits, because concept is very general. Limits should be equal to the value of the function at that particular point. Limit at that point should be equal to the value of function at that point. Okay, if the function is partwise, then just check RHL and LHL. Okay. Now continuity of composite function. We know composite functions, right? Continuity for f of g of x. Composite function means FOG. FOG. F of g of x. Continuity, when we have to check the continuity for f of g of x. That's it. That is called continuity of a composite function at some value. Okay. So let's see what should be the approach towards that. See, big functions will be given to you. You're not always supposed to find FOG. You're not always supposed to find FOG, right? Although we know, if you have studied functions, there can be one way that you're finding f of g of x, right? In f of x, everywhere you're putting 2 g of x plus 1, 2 g of x square plus 2, then g of x plus 5, then finding f of g of x. It will just become more complicated. Okay, at some value. Instead, what we are supposed to do is we are supposed to find left hand and right hand limit only. No, that we'll be able to do. That we'll be able to do easily only without finding actual f of g every time. That's what I'm trying to say. For example, over here, suppose if you are supposed to find f of g of 2, f of g of 2, that means f of g of 2. That means we are supposed to find f of g of 2. This is what we are supposed to find. Correct. Now, what is g of 2? G of 2 is g of 2 can be obtained from here when x is greater than or equal to 2. The g of x becomes this. So g of 2 will be 2 into 2 minus 2. This value will be obtained. This value will give us g of x or g of 2. 2 into 2 minus 2. Correct. So g of 2 will become 4 minus 2, that means 2. So now we are supposed to find f of 2. What is f of 2? F of 2 can be obtained from here. F of 2 will be 2 plus 5. Because when x is greater than or equal to 2, f of x becomes this. So f of 2 will be 2 plus 5. That means 7. Similarly, if you are supposed to find f of 3, whenever x is greater than 2, this is the function. So f of 3 will be 2 into 3 minus 2. So not f of 3, g of 3. Sorry. F of g of 3 we are supposed to find. I think I said f of 3, right? Sorry. G of 3 will be x is greater than 2. That means function's value will be this. So g of 3 will be 2 into 3 minus 2. 6 minus 2, 4. So basically we will be finding f of 4. What will be f of 4? Whenever x is greater than 2, this is the function's value. So f of 4 will be 4 plus 5. That means 9. Similarly here, although you can find, tell me what will be f of g 1. Tell me f of g of 1. Tell me what will be f of g of 1. Whenever x is less than 2, g of x becomes x minus 1. That means f of g of 1 we are finding. If we are finding f of g of 1, g of 1 will be this x minus 1. G of 1 means 1 minus 1, 0. So we are finding f of 0. What will be f of 0? Whenever x is equal to 0, this is the value of function. So f of 0 will be 0 square plus 2. That means 2. Now similarly, hello Mr. Unknown. Now similarly, if we are able to find value of FOG at a given point, what we have found? We have found FOG at 2, 3 and 1. Can we not find FOG for 1 plus or 1 minus or 3 plus or 3 minus, 2 plus and 2 minus? We can find LHL and RHL also, right? Similar way, in this with the same way, we don't need to actually find the main function FOG. We can similarly find for 2 plus, 2 minus, 3 plus and 3 minus also, can't we? For example, in the same thing only, suppose we are instead of FOG, we are supposed to find FOG of 1 minus. Let's say, suppose we want to find FOG 1 minus, right? So what will it mean? It will mean f of g and g of x instead of g. We need to find g function at 1 minus, slightly smaller than 1. when x is slightly smaller than 1. Slightly smaller than 1. Slightly smaller than 1 means smaller than 2 only. That means function value will be x minus 1. Now your x is slightly smaller than 1. That means 0.999 something. That means this x minus 1 will also be slightly smaller than 0. Correct? Yes or no? See, this, instead of writing this thing, something which is slightly smaller than 1 minus 1 I'm doing. So it will be slightly smaller than 0, na? Or slightly greater than 0. Something which is slightly smaller than 1, that means 0.99 something. Minus 1 will give me negative side of 0. That means slightly smaller than 0. So I'll have 0 minus. So this will become f of 0 minus. Correct? Understand this very carefully. F of 0 minus we'll get. F of 0 minus, let's come over here. Whenever x is less than 0, this is your f of x. This is your f of x. Whenever x is less than 0, this is your f of x. So f of 0 minus will be 2 into 0 plus 1. That means 1. Suppose here we are supposed to find f of g of 1 ho gaya. Let's say 1 plus we are finding. Suppose 1 plus we are finding. Okay, 1 plus. F of g for 1 plus. This means f of g when x is slightly greater than 1. Okay, slightly greater than 1. Same value will come. Even if it is slightly greater than 1, same. Because whenever, until and unless x is smaller than 2, we'll get this thing only. But now x is slightly greater than 1. So x minus 1 will become, whenever x is slightly greater than 1, 1 point something, x minus 1 will be positive. 1 point something minus 1, that means 0, slightly greater than 0. That means 0 plus we'll be getting. So this will become 0 plus. Got my point? Here your 1 plus, that means this thing, at whenever x is slightly greater than 1, then function's value will be x minus 1. But your x is slightly greater than 1 this time. So x minus 1 will be slightly greater than 0. In the first case, here x minus 1 was slightly lesser than 0. In this case, we have x minus 1 slightly greater than 0. Correct? So 0 plus. When x is 0 plus, when your, so f of 0 plus, that means value of f of x when x is greater than 0. That means x square plus 2. That means 0 square plus 2. That means suppose let's try finding f of g 2 plus. 2 plus. Okay. 2 plus slightly greater than 2. That means this value. Right? Slightly greater than 2. That means 4 minus 2. Slightly greater than 2. This will become 2 into 2. 4 minus 2. 2. But slightly greater than 2. That means 2 plus. So we'll be having f of g of 2 plus, which will be f of 2 plus. Correct? F of 2 plus, f of g of 2 plus will become f of 2 plus, because g of 2 plus, that means when x is slightly greater than 2, what value will have? We'll have 2x minus 2, where x is slightly greater than 2. So 2x minus 2 will also be slightly greater than 2. 2 into 2, 4 minus 2 will be slightly greater than 2, because 2 is not exactly 2, it is slightly greater than 2. So this will become 2 plus. Now f of 2 plus, when x is greater than 2, value is 2 plus 5. So 7. Value will 10 to 7. Not exactly 7, 10 to 7 we can say. But yeah. This is how, what I'm trying to say, you don't actually, when this is given to you, you don't always go on finding f of g of x. By the normal method of finding f of g of x, putting g of x everywhere instead of x, and then finally finding f of g of x. No, you need to find LHL and RHL. Basically, LHL and RHL of f of g at 1 will be 1 and 2. So f of g is not continuous at 1, because LHL and RHL are different at 1. So this is how you can conclude. Let's see a question based on it. For example, over here only, f of x and g of x are these, then check the continuity of FOG of x at x equal to 2. Now, generally, why I'm saying that use this method, because generally in books also they'll first find f of g of x sometimes, which is not advisable, right? That will just complicate your method, that will just complicate your solving. Instead, find LHL and RHL at 2 using the concept we just learned, right? So LOG, LHL, suppose we are supposed to check. Suppose we are supposed to, at x is equal to 2, suppose we want to check LHL. Left hand limit of f of g of x, LHL means limit x tending to 2 minus for f of g of x, or f of g of x like this. This will be equal to what? What will this be equal to? This will be equal to, now g of x at 2 minus, when x is less than 2, it is x minus 1, right? When x is less than 2, slightly less than 2, it will be x minus 1, 2 minus 1, 1. Correct? Slightly less than 2 or greater than 2? Right? G of x will come out to be slightly less than 2, because x is slightly less than 2, and x minus 1 will also be slightly less than 2 then. Slightly less than 1, guys. Nobody's saying anything. Right? F of g of x, just like we did just now, we want to check at x tending to 2 from the left hand side. That means x tending to 2 minus, slightly less than 2. Slightly less than 2, that means we'll get the g of x from here. Now x is slightly less than 2. So g of x will be slightly less than 1. X is, let's say, something out 1.99 something. Right? So 1.99 something minus 1 will be 0.99 something. That means slightly less than 1. Right? So this will become f of minus 1, f of 1 minus. Right? F of 1 minus slightly less than 1. That means from 2x minus 1. Right? 2x minus 1 only, no? When x is less than 1. Correct? So what are we doing? We are finding limit x tending to 2 for f of, where f of 1 minus, f of 1 minus means value when x is slightly less than 1. That means for 2x minus 1. Okay. So it is going to tend to 4 minus 1, 3. Correct. Now similarly we can find x tending to 2 plus right hand limit for f of g of x. It will become f of g of x when x is slightly greater than 2, 2x minus 2. Right? So 2x minus 2, 2x is slightly greater than 2, 4 minus 2. So x is slightly greater than 2, 4 minus 2, 2, and it will be slightly greater than 2. So basically we'll have f of 2 plus. F of 2 plus, again we'll go here and we'll have x plus 5. F of 2 plus means when x is greater than 2. So it will become 2 plus 5. That means limit x tending to, this was 2 minus, this is 2 plus, for x plus 5. We'll be checking for x plus 5. This will come out to be 7. Correct? So 3 and 7, LHL and RHL are not equal. So FOG of x is not continuous at x equal to 2. This is how we are going to check. Remember this, right? Here 2 plus, here 2 minus. At 2 minus, we are getting FOG's value at is equal to 3, and at 2 plus, we are getting the value as 7. Okay, let's see one more of the same type. Okay, this is, I think, a very good question. This, I think, is a definitely very good question. Try to read the question and comprehend it once on your own. I'll just be back. I'll give you some time. Please read the question and try to comprehend it. Here they have not given, here the concept is not as simple as the last question, right? We don't have to just find the continuity of f of g. We have to find the continuity at how many points will it be discontinuous? For how many points will it be discontinuous? Question is good question. Came in 21, a bit tricky, but a good question. Try to read it. Okay. F of x is given to you, g of x is given to you, t is the greatest integer. Then in open interval -1 to 1, the number of points where FOG is discontinuous is equal to, for how many points, at how many points between this interval -1 to 1, FOG will be discontinuous. That's what they are asking. Now, and if you look at g of x, we can check the continuity at 0. Correct? We can check it at 0. So basically for this interval -1 to 1, it's better to check the between -1 to 0 and then 0 to 1. Correct or not? We should check from -1 to 0 and 0 to 1. First, let's find FOG. Okay, here we should find FOG first, right? Our approach should be, in this case, we'll have to find FOG. There is no other go. There is no other go, because here they are not just asking you to check the continuity of FOG, and they have not given two different ones. They are asking you to check the continuity in an interval. So it's important to know FOG. It's important to look at f of g. So how? For that, we'll have to find the f of g. F of g will be nothing but, in f we'll put everywhere g of x. That means it will become greatest integer function of 2 times of g of x whole square plus 1. Okay, this is it. This is what it's going to be. Now 2 times of g of x whole square. This f of g of x will change when x is less than 0 and when x is greater than or equal to 0. Okay, when x is less than 0, this thing will become 2 times of 2x minus 3 whole square plus 1. Correct? And when x is greater than or equal to 0, this will become 2 times of 2x plus 3 whole square plus 1. I'll try to explain very slowly, but understand very carefully. Okay, good question. Finding f of g of x. So this will be our f of g of x. Correct? This is going to be our f of g of x. When x is less than 0, this will be f of g of x. When x is greater than 0, this will be f of g of x. And here finding f of g of x was easier than the other parts. Okay, that is why. This is why the complication is another thing in this question. The complication is not finding f of g of x. But when f of g of x is looking difficult to be found, you use the concept which we just learned. Finding left hand and right hand limit just by using f and gx. Both. Here, finding f of g of x was not that difficult. So first thing is that we write f of g of x. Now we'll be able to look at it very carefully. Now see, we have found f of g of x when x is less than 0 and x is greater than 0. We have to talk about its continuity between -1 and 1. And we have to tell at how many points will this be discontinuous between -1 and 1. One thing we forgot, putting the greatest integer function. Yeah. As soon as I put the greatest integer function, what should strike your mind? It should strike your mind. You should recollect that greatest integer function, when it is discontinuous, whenever this interior part will be an integer. Whenever this thing becomes integer, there only this particular function will be integer. That's why it was important to write f of g of x. Correct? But we'll check the continuity from -1 to 0 and -1 to 0 and 0 to 1. We can check. But at 0, what is the position? We'll also have to check at 0. What is the continuity status at 0? Whether it is also discontinuous at 0, then we'll have to include that. Although we can check between -1 and 0, where all this thing will become integer, that we know how to check. Right? We'll use just intervals for that. Between 0 to 1 also, we know how to check whether this thing will be an integer or not. Very good, Sayed Roshan. Amazing. Right? Between 0 to 1 also, we know how to check whether it is integer or not. But at 0, we'll have to check separately. Right? At 0 also, we need to check whether it is continuous or not. Otherwise, 0 will also be a point of discontinuity. So at 0, how will we check? LHL and RHL. Right? When x is less than 0, this thing will become 2 into 0 minus minus 3 whole square. 0 minus means this will tend to 0. 0 minus 3, right? Minus 3 whole square. I'll write over here 2 into greatest integer function of 2 into 0 minus. 2 into 0 minus will be 0 minus only, minus 3 or 0 minus 1 can be 0 minus minus 3 whole square plus 1. This will be, what will this become? This will become minus 3 whole square, 9. 9 into 0 minus 3. 0 minus means slightly smaller than 0. Slightly smaller than 0. Negative point something something, 0 point something something. Okay. Minus 0 minus, so minus 3 square, that means 9 point something. Positive 9 point something. 9 point something into 2. That means 18 point something. Right? 18 point something plus 1. 19 point something. Okay, will be equal to 19. Greatest integer will make it 19 only. Greatest integer will make it 19 only. Greatest integer is making it 19 only. So this is your LHL. What will be your RHL? RHL 2 into 0 positive. Now RHL, when x is greater than 0. When x is greater than 0, this is your value of the function. 2 into 0 positive plus 3 whole square plus 1. 0 positive means this is slightly greater than 0. Slightly greater than 0 plus 3. Square will be slightly greater than 9. 9 into 2, 18. Slightly greater than 18. 18 plus 1, slightly greater than 19. So this will also come out to be 19 plus, that means 19 only. And value of function at x is equal to 0. Here put x is equal to 0 over here. So it will become 9 into 2, 18 plus 1, 19. Value of function, that means f of g of 0 is anyway coming out to be equal to 19. So here LHL, RHL and value of function at x is equal to 0. Value of f of g at x equal to 0, all are coming equal to one another. That means at 0, it is continuous. 0 is not the point of discontinuity. Apart from 0, this function will be discontinuous wherever this thing, this internal part becomes an integer. This will be discontinuous whenever this part becomes an integer. A greatest integer function is always discontinuous at integers. Correct thing? So check for anyone. Let's say, let's open another page. 2x minus 3, 2x minus 3 whole square into 2 plus 1. Now, x, where is x? X lies between, first we'll check between 0 and minus 1. Between 0 and minus 1, what will happen? When x is less than 0, this is the function. This is your function. 2x minus 3 plus 1, right? This is your function. When x is less than 0, when x is between 0 and minus 1, we are checking from, now we are checking for discontinuity points from minus 1 to 0 and then 0 to 1. So minus 1 to 0, what will be the function? This thing will be the function. Right? Now, x is between minus 1 and 0. So 2x will be between minus 2 and 0. This is how you are going to check. Like you have to make the function. Now minus 3, do minus 3 both the sides. 2x minus 3. So minus 3 and minus 5. Correct. Now square both the sides. Squaring both, square both the sides. So 2x minus 3 whole square. If squaring we are doing, then the inequality signs will be changed. This will become 25. This will become 9. What is the thing that we need to create? 2x minus 3 into 2 whole square plus 1. Into 2, again we have to do. So this will become 50. This will become 2 into 2x minus 3 whole square. This will become 18. Correct? This is how we can make the function and check whether it will, where all it, at how many integers will be there between these two values. Now plus 1 also we have to do, plus 1 or minus 1? Plus 1. Plus 1 also we have to do. So 2 into 2x minus 3 whole square plus 1 will be equal to 19, will be greater than 19 and smaller than 51. Now we just need, we know that this thing, if we put greatest integer function on it, then it will be discontinuous only on integers. We need to know how many integers between 19 and 51. Tell me how many integers between 19 and 51. Between 19 and 51. Okay, remember this was closed interval. As this was open interval, not closed. Okay, so you don't have to include 19 and 51. So between 19 and 51 we have 31, 20, then 10, 31 integers. We have 31 integers. 31 integers between 19 and 51. Similarly, when we'll check for x greater than 0 and smaller than 1, same thing will be obtained, and we'll have 90, between 19 and 51 we'll have 31 integers. 31 will be obtained over here also. When you'll check for x between 0 and 1, when x is between 0 and 1, what will be your function? 2x plus 3 whole square into 2 plus 1. Same thing you'll have to create like this only, and you'll get 31 only. You can be sure. By this only you can understand you'll get 31 integers only. Right? So 31 integers here, 31 integers here. 62 is your answer. 62 is going to be your answer. Repeat this question once again. Solve it on your own. Repeat and revise. There is high probability for similar type of question to appear again in 2025 or later, but yeah, same variety can appear. Sure. In 24 also similar, not exactly similar, but yeah, similar thing was used. So you should know what to do when you are checking the continuity points or discontinuity points in the given interval. Okay. Let's do one more of the similar type. Find the points of discontinuity of f of g of x. Points of discontinuity. Again. Now, you know the functions are very simple. Right? You can see that the functions are very simple. It's not going to be difficult. You know your f of x is x plus 1 and x minus 1. You know it will be always continuous. X plus 1 always continuous. X plus 1 upon x minus 1 will be always continuous. Only at x equal to minus 1 it will not be continuous because it will not be defined. Only for x is equal to 1, this will not be defined. Correct? And your g of x, if you look, your g of x is 1 by x minus 2. It will always be continuous on. Sir, when will English might start? Shagabu, yeah, most probably by November end or December first week for 26. Yeah, December first week, November end, definitely yes. Okay, this will be continuous, but only non-continuous at x equal to 2. 1 by x limit, it will be only not defined at x is equal to 2. Like if we find LHL, RHL, the only problem will be obtained when x is equal to obtain. Limits will be undefined when x is going to be equal to 2, when x is going to be equal to 1. So only at x is equal to 1 and x is equal to 2, this is undefined or discontinuous. These two, not FOG. I did not comment on FOG right now. I said f of x will be discontinuous at x is equal to 1. F of g of x will be discontinuous at x is equal to 2. That's what I said. Okay. I didn't comment on f of g of x till now. The question is asking you to find the points of discontinuity of f of g of x. So first, what is f of g of x over here? What will be f of g of x? F of g of x, very simple. In f of x only, put g of x. Instead of x, put g of x. So g of x plus 1 divided by g of x minus 1. G of x is 1 by x minus 2. So 1 by x minus 2 plus 1 divided by 1 by x minus 2 minus 1. This will become 1 plus x minus 2 divided by 1 minus x plus 2. So numerator will become x minus 1, denominator will become 3 minus x. Right? This will become x minus 1 and this will become 3 minus x. This is your f of g. This is your f of g of x. Now, if you remember the functions, you know that when here the common mistake is that after finding f of g of x, you'll say that there is only one point of discontinuity, that x is equal to 3. Yes, x is equal to 3 is one point of discontinuity. There is one more point of discontinuity. Okay, because according to definition of f of g of x will be undefined in two conditions. It will be undefined if g of x is undefined. Right? If g of x itself becomes undefined, there is no point in finding f of g of x. If g of x itself is undefined, f of g of x will not be found. It will be undefined. Right? So g of x is undefined also makes f of g of x undefined. If g of x, or second point is entire f of g of x is undefined. Name is not yet decided, Shagabu. Let's do one thing. Keep commenting the same thing on the videos at least. Like after the lecture is finished, comment. Like if 2-3 of you also comment about the batch, no, it will be sooner to release, because obviously it's not entirely in my hands. There are certain parameters on that, but on the videos, comment this thing, that when the batch of 2026 English batch will be starting, that will put more, what do we say, pressure. Okay. What was my point? F of g of x will be undefined when g of x is undefined, and also when f of g of x is undefined. F of g of x is undefined at x is equal to 3. Okay, one point of discontinuity. But g of x is undefined. G of x is undefined at x is equal to 2. So when x will be equal to 2, at that time also f of g of x will be undefined. So there are 2 points of discontinuity. There are 2 points of discontinuity, not just 2 points of discontinuity. This I'm writing x equal to 3 and x equal to 2. It will be discontinuous at 2 different points. General mistake is writing only x equal to 3. f of g of x is not only is undefined not only when entire function is undefined, it is also undefined when internal function, that means g of x, is undefined. Remember this. Sorry. Okay, let's move ahead. Some more parts of this chapter. I hope not much time has passed. Okay, I'll try to finish up as yeah. Okay. Continuity in an interval. Continuity in an interval, although there is no there should not be any need to learn this separately. This is quite understood. I'll just write some things. Okay, you tell me, you already understand that or not. If I write y equal to f of x, suppose there is this function y equal to f of x and it is continuous. This function is continuous in interval, closed interval, sorry, open interval a comma b. Suppose it is continuous in open interval a comma b. When can this happen? This can only happen if f of x is continuous for all x. If f of x is continuous for all x belonging to a comma b, obviously. In entire interval a comma b, f of x will be continuous only when at every point between a and b it is continuous. This is quite obvious, right? I don't need to say this, but it is said. This is one way of saying the definition of continuity in an interval. Second part is more important, that when y is equal to f of x is continuous, when is y is equal to f of x continuous in the closed interval. If they are talking about closed interval, here we need to take a little bit care, pay attention, right? This in closed interval. In open interval, suppose my graph is like this, right? This is a, this is b. Okay, this is continuous in the open interval a and b. So it is supposed to be continuous at every point between a and b, correct? But what about closed interval? Suppose if I want to make it continuous in the closed interval of a and b, when can I say that it is continuous in closed interval a and b? First thing that I need to know is that it's, sorry, just a minute. First thing, obviously it should be continuous. First thing is that it is continuous in open a and b. Obviously this is but obvious that in open a to b it should be continuous. But at the points, at the end points, how do we check? Now if I want it to be continuous in closed a to b, that means I want it to be continuous only inside of this interval. I don't need to go outside of this interval. So at a, do I need to check the left hand limit? No, only right hand limit I need to check, because left hand limit is going beyond the interval. Right hand limit will be in the interval. So I just need, second point is my right hand limit RHL at a should be equal to function's value at a. Or one more way of writing is limit x tending to a plus, right, for f of x should be equal to a. Oh, not a, should be equal to f of a, right? And third point says for b I don't need to check the right hand limit, I need to check only the left hand limit, and my LHL at a should be equal to f of b. LHL at b should be equal to f of b. Or I can also say limit x tending to b minus for f of x should be equal to f of b. Simple to understand concept. Continuity in an interval is nothing difficult to digest or difficult to understand. A function simply will be continuous between the interval a and b, between the open interval a and b, if it is continuous for every point between a and b. In closed interval means, suppose if my a, this is a and this is my b, closed interval. Now if I need to check if it is continuous in closed interval a and b, I only need to check the three things: that it is continuous between open a and b, it is the LHL at a, sorry, RHL at a is equal to value of function at a, LHL at b is equal to value of function at b. Why? Because even if this graph is breaking exactly at a and going somewhere else, I don't need to worry. I don't need to worry. It's breaking at a, but but in the closed interval it is continuous because this is covered. Right? After that, out of that it is breaking. I don't need to bother. Okay. So okay. Now the next thing is types of discontinuity. Okay, wait. Something we have missed here. No, I don't think. This thing you have understood, right? That if the graph is running somewhere ahead, somewhere away, at A, it is breaking at A, but at this point it is continuous. RHL over here is equal to function's value at A is equal, and here LHL at B is equal to function's value at B. If they are equal, that means it is continuous in the closed interval A to B. No need to worry. Actually, there were some diagrams I forgot to place over here. That's right. Okay. Types of discontinuity. Types of although you know discontinuity means graph is jumping, right? That means your LHL, RHL are not equal, or LHL, RHL are equal, but they are not equal to value of function. So on these bases, only on these conditions, sometimes types of discontinuity are discussed. Many books, this is not given only, in many books, this will be given in very brief form somewhere in the notes. But sometimes it is observed that questions in competitive examinations like JEE come with the relevance of these specific terms, that which type of discontinuity it is, whether it is removable, irremovable, first kind, second kind, jump discontinuity. Different names are there based on their based on small changes in the definitions. So let's understand how. Okay. Discontinuity. Majorly, there are two types of discontinuities. Only two types. Either discontinuity will be removable. We'll study about this ahead also in differentiability. Right? Either discontinuity will be removable or it will be irremovable. Removable, non-removable, irremovable, same thing only. Okay. Sometimes they'll make the name based on definition only. So general idea we are getting over here. Right? Discontinuity majorly can be only of two types. Either it will be removable or it will be non-removable or irremovable. Removable is very simple to understand. Removable means your LHL at A is equal to RHL at A. But these two are not equal to value of function at A. That means something like this. Your graph is somewhat like this. Okay, graph is somewhat like this. At A it is not defined, or at A it is giving a missing point and somewhere else its value is there. Right? LHL and RHL are equal. LHL and RHL are equal, but they are not equal to f of A. This is not equal. Right? LHL, RHL are equal, but they are not equal to f of A. This is called removable discontinuity. Okay, keep listening carefully. Second thing is irremovable discontinuity. Irremovable discontinuity. Now, irremovable, again, Just a minute. पानी कहाँ गया? चलो, leave it. Okay, now on removable also there are two more types. I'll tell them, but first let's understand what is irremovable discontinuity. Obviously you must have understood what is irremovable. If this is removable, what will be irremovable? Irremovable means LHL RHL itself are not equal. Leave about f of a. That means LHL RHL itself are themselves are not equal. Okay, on the basis of this also there are two types, right? On the basis of this also there are two types: discontinuity of first kind and discontinuity of second kind. I know a bit complicated, not complicated, bit too much. Why? But yeah, in questions they might use these names, so you need to you need to know this. You need to know this. What is the difference of 0 divided by 0? What difference of 0? What difference of 0 divided by 0? Devil gaming. I don't know what 0 by 0 is indeterminate. Anything can be the answer. How to avoid spelling mistakes? Ask your English madam. Even I do a lot of spelling mistakes. Not a problem. Il Sahil. Differentiation you are asking? Devil gaming, what are you asking? First explain me. Are you asking about differentiation? Devil Sahil? Please note this down, everybody. You're asking what is the differentiation of 0? The differentiation of 0 is 0 only. 0 by 0 is not defined. So you'll have to apply limits there. Diffraction. 0 by 0 will not be defined, beta. Please note this down, everybody. If 0 by 0 itself is undefined, then its differentiation will also be undefined. No? Simple to understand. Where did the screen go? Okay, leave it. Yeah, till here, note it, because you know I'm asking you to note down, because in case you don't understand my handwriting, you can ask over here only, because I know it's horrible. First kind and second kind. Now, what did I say? A removable means LHL equal to RHL, but both of them are not equal to f of a. Irremovable means LHL itself is not equal to RHL. Okay, now on in this only there are two kinds. First kind means very simple, same thing. LHL is finite, RHL is finite, but both are not equal. Both are finite but not equal. In this case, LHL and RHL. LHL is undefined. Undefined or not finite. Something like infinity for 1 by x. Those type. LHL or RHL does not exist or are not defined. LHL or RHL, one of them, LHL or RHL, does not exist. Does not exist means or are undefined. This is the second kind of irremovable discontinuity. First kind of irremovable discontinuity means LHL and RHL are just not equal. They are finite. They can be found, but they are finite. Devil, I don't have that book right now. Okay. Second kind. Now, Furthermore, there are more categorizations. Sometimes this is this second kind is also known as essential irremovable or essential discontinuity. You can call this one as essential discontinuity. Please note this thing down if you have not done this before. Essential discontinuity. This is going to be called as essential discontinuity. One more name is there. And here, removable, generally the parts or the further categories are not given. But there are two types. One is isolated point discontinuity, and there is missing point discontinuity. Right? In removable, there can be two cases: isolated point or missing point. You saw that in the graphs. Suppose something like this, that it is discontinuous at x is equal to a, but f of a is somewhere. The value of f of a is there somewhere. So point is isolated, and here f of a is not there only. F of a is not defined only. Right? There is a missing point. F of a is not defined only. Suppose f of a is not defined only. In that case, this is called missing point discontinuity. F of a is just isolated. It jumped somewhere else. It is defined, but it's jumped. Its value is somewhere else, not on this curve. So that is isolated point. This is isolated point discontinuity. This is missing point discontinuity. Okay. Anything else? This first kind is also called as jumped discontinuity. This is also first kind. The first kind, discontinuity of the first kind is also called as jumped discontinuity. Okay, discontinuity of the first kind can also be called as jumped discontinuity. The rest, nothing more will no more categorizations will be there. Sir, see the question in phone and please try to solve in easy method exercise 5.5 question 6. Okay, let's complete this first. Limit f of x where x, okay, this we saw, right? So removable discontinuity, you know, LHL will be equal to RHL, but f of a is not equal to LHL and RHL. This is your removable discontinuity. Missing point discontinuity means this is isolated point removable discontinuity. This is missing point removable discontinuity. Over here, examples, for examples, types of discontinuity. Here, see, this is which type? This is removable discontinuity, right? Instead of, it means we can remove the discontinuity by using some suitable function value, right? Here we can remove the discontinuity by using some suitable function value. Jumped discontinuity, discontinuity of the first kind. LHL and RHL itself are not equal. LHL and RHL itself are not equal. That means the graph is jumped somewhere. This is jumped discontinuity. Okay, this is jumped discontinuity. Try to send the question, Devil Gaming, right now. If you can send in the chat box. I don't know how. I don't have the NCERT app right now. And please, right now, pay attention. I'm sure that you'll be able to solve if you listen to this carefully for the entire session. LHL and RHL does not exist only. In these cases, LHL and RHL won't exist. When x is not equal to 0, this thing will not exist. 1 by x will become undefined. Here also, LHL and RHL will not exist only. So this is discontinuity of the second kind. Or we can call it essential discontinuity. We cannot do anything about it. Okay. Here it's not sign. There is no spelling mistake. I hope we know signum. Right? Here they've given the options on the basis of types of discontinuity. So that is why we need to know this. That's why we need to learn this. They've given the questions based on types of discontinuity. This can happen in your competitive examinations as well. Okay. The function f of x is this, has jumped discontinuity, removable discontinuity, right? What does it have? Obviously, we have to check at some value. We have to check at some x equal to 0. We are supposed to check at x is equal to 0. This will also be given to you. We are checking at x is equal to 0. So what is our function? F of x. Let me change the color. Our function is f of x equal to mod of 2 signum 2x plus 2. Right? 2 signum 2x plus 2. And we are checking at x is equal to 0. Now, what will be your f of x? You know, this mod of 2 signum plus 2 will become, when x is greater than 0, signum 2x will be positive 2. When x is equal to 0, signum 2x will be equal to 0. When x is less than 0, signum 2x will be minus 2. Right? I'll write over here signum 2x, or wait, this entire thing 2 signum 2x will be equal to positive 2. This will be positive 1 and 2 into 1 will become 2 when your x is greater than 0. Right? It will become equal to 0 when your x is equal to 0. Signum 2x will become 0 when x is equal to 0. Signum 2x will become minus 1 when x is less than 0, and entire thing will become minus 2 when x is less than 0. Correct? So mod of 2 signum plus 2, what will this be equal to? Mod of 2 signum 2x when x is not equal to 0. When x is not equal to 0, what will this be? This will be 2 only. When x is not equal to 0, when your x is not equal to 0, this value mod of 2 signum 2x will be equal to either, it will be equal to 2 only. 2 signum 2x will be 2 only. If x is greater than 0, then plus 2, mod will make it positive. Positive only. X is less than 0, minus 2, mod will make it positive. Right? So 2 plus 2, it will become 4 for x not equal to 0. It will be equal to 4 when x is not equal to 0. When x is equal to 0, what will it be? When x is equal to 0, it will be equal to 0 plus 2. That means 2. So this is your function. For x not equal to 0, it is 4, and for x is equal to 0, it is 2. Which type of continuity it is? Removable, because your LHL will be equal to RHL. When x is not equal to 0, LHL and RHL will come out to be 4. When x is equal to 0, it will be 2. LHL and RHL are equal, but they are not equal to f of a. That means removable discontinuity. Removable discontinuity. Okay. Let's look at one more. Here also options. Again, A, B, C and D. Options again. Just a minute. Look at the function. When x is equal to 2, function is equal to 3 by 5. Not a problem. When x is equal to 2, function is equal to 3 by 5. Not a problem. When x is not equal to 2, what is the function? X minus 2 by mod of x minus 2 multiplied with x square minus 1 upon x square plus 1. Now, this thing is not going to bother me. Now look at it. When x is not equal to 2, this will be your f of x. Right? F of x is this. This will be your f of x when x is not equal to 2. When x is equal to 2, it is 3 by 5. When x is equal to 2, it is 3 by 5. That means definitely it is discontinuity. Why? Because LHL and RHL can be equal, but f of x is not equal to them. Okay, maybe. But now f of x, leave f of x. Now if we want to talk about LHL and RHL, LHL and RHL will be affected because of this mod only. Correct? At mod only. And we are checking the discontinuity or continuity at x is equal to 2. Correct? Correct. This mod only is going to affect the entire value. Otherwise, the value, this will not affect anything. The numerator will not affect anything. X is anyway not equal to 2, so there is not undefined case. Now, we just need to know about LHL and RHL. LHL means when the value of x will be slightly lesser than 2. slightly lesser than 2, 1.99 something minus 2. This thing will open with negative sign. This entire thing will be negative. When we'll check LHL, this will open with negative sign. That means x minus 2 upon minus of x minus 2. This will get cancelled. Answer will be x square minus 1 upon x square plus 1. Minus of x square minus 1 upon x square plus 1. What will be RHL? Right? Minus of x square minus 1 upon x square plus 1 will be your answer. Right? Here you'll put limit value, that is different thing, but negative sign will be there. Now RHL when you'll check, that means slightly greater than 2. RHL at 2, this is at 2, LHL at 2, RHL at 2. Slightly greater than 2 will make this as positive. Right? That means this will open with a positive sign only. So x minus 2 upon x minus 2 will get cancelled. Final answer will be x square minus 1 upon x square plus 1. Whatever this is going to be positive. This and this is going to be negative. This is going to be positive. LHL and RHL are not equal. That means irremovable, non-removable discontinuity. We cannot remove this discontinuity. We can only remove if LHL RHL are equal, but they are not equal to f of a. Here LHL and RHL are definitely going to be different because this mod will be affected in the neighborhood of 2. So that means it has non-removable discontinuity for sure. Correct, Ji? So types you can easily check. Now last thing is this intermediate value theorem. Intermediate value theorem is nothing, it's just a way of saying things. Although this is not taught generally, including with continuity, it was supposed to be taught in differentiability part, but it's okay. Here also we can understand, so that in the differentiability part we'll be able to understand this better. What does it say? It says that if a function f of x is continuous in the interval a to b, right? If f of x is continuous in the closed interval a b, then definitely there has to be some value c, right, for which f of c will be equal to k. That's what it is saying, nothing much. Basically what intermediate value theorem wants to tell only one thing, that if your function is continuous between a and b, that your function is continuous between a and b, closed interval, then definitely for all these values, suppose f of a, suppose your f of a is some value c, and your f of b also is some value. This is going to be your f of b, right? So if your function is continuous between a and b closed, or even open also you can say, but open you cannot have f of a and f of b, that is why I'm saying closed. So definitely for all the other values between a and b, there are going to be values over here. You'll obtain the value of function for all the values between a and b, but obvious, because it cannot break. So for all the values between a and b, you are going to get corresponding values of the function, right? So according to definition, it says that there is going to be some c between a and b. There is going to be some c between a and b such that f of c will be equal to k. That's what it is saying. I just didn't like to speak FCK. Sorry. Same special case. Special case means if your f of x is continuous between a and b, then there is going to be at least one value of x such that f of c, there is going to be some midpoint. It's just saying that there is going to be some midpoint. Here only it's saying that definitely there will be some value for which f of a plus f of b by 2 will be equal to f of c. Right? There will be some c midpoint. They'll call this c as midpoint. Not exactly between a plus b by 2, but yeah, there will be some c for which f of c will be equal to f of a plus f of b by 2. That means there will be a midpoint over here. F of a plus f of b by 2 will be the midpoint over here in this part. it says that there is definitely going to be some value c for which f of c will be equal to f of b plus f of a divided by 2, will be midpoint. Second thing, it is saying if f of x is continuous in a and b, then f of a into f of b will be less than 0. Yeah, this also I'll explain. It's saying that suppose your function is continuous between a and b. Okay, function is continuous between a and b, and your f of a into f of b is equal to 0. That means at f of a, this is a, f of a is negative, f of a is some negative thing, f of a is your negative, and your f of b is positive. Okay, between a and b your function is continuous in closed interval a and b, and f of a is negative but f of b is positive. If this is the case, then definitely there'll be 1 0. That it is definite, it is going to start from here, and it is continuous. It is not going to go anywhere, it is not going to break anywhere. Then in this case we can always say that this will at least have 1 0. It can have more zeros also, it can go like this also, it can go come back like this, but it should be continuous. At least 1 0, at least one time it will have to cut the x-axis. If it is continuous, where will it go? It will go on the other side, right? F of a is negative, f of b is positive, then it has to be like this, from negative side to positive side of y-axis. That means it has to go through crossing the x-axis. That means at least 1 0 it will definitely have. Okay, this is what the question is trying to say, the theorem is trying to say. We can take one example also on the basis of this. Let's say let's take some simple function. Okay, x minus 1 plus cos pi. Let's say let's take a continuous function. This is a continuous function, x minus 1 plus cos pi. Let's say this is our function f of x. Now related to this, a question can come that show that f of x has at least one root in the interval. Show that at least one root in interval 1 comma 2, or let's say 1 comma not 2 plus 3, between 1 comma 3. So how will we show that? This is the function, we know it is continuous, simple linear function, it is continuous, right? Everywhere continuous. Now what we'll do, we'll just check the value. We'll check the value at f of 1. What will be f of 1? F of 1 will be 0 plus cos pi, right? Sorry, f of 1 will be 1 minus 0 plus cos pi, right? So 0 plus cos pi, f of 1 will become cos pi. Cos pi means negative 1. F of 3 we'll check. What will be f of 3? F of 3 will be 3 minus 1, 2 plus cos pi. 2 plus cos pi. That means 2 minus 1, that means 1. Correct? F of 1 is f of 1 into f of 3 is less than 0. That means f of 1 is negative and f of 3 is positive. This and your function is continuous in the interval 1 to 3. That means definitely it is going to have at least one root in the interval 1 to 3. This type of question can be framed using this theorem. So remember this theorem. If the function is continuous in the interval, right, and its value at one point of interval is negative and another point of interval is positive, or vice versa, in that case we'll always have at least 1 0 of that function. That's what the intermediate value theorem says. Now there are some more theorems, Rolle's theorems and others. In differentiability, in the next lecture we'll study them. In this lecture, just revise this much part. For the differentiability you'll need this also, right? Differentiability tags along with continuity, and complete differentiability and continuity will be used in other chapters also. This chapter should be cool enough. Very important chapter. Good weightage is there, easy concept is there, limits needs to be revised. Most of the things we have completed. You'll be able to solve most of your questions now. Simple concept. If you remember the concept, if you're thorough with the limits, you're good to. Okay then, I should take my leave. Thank you so much. Bye bye. Take care. Sayonara. See you in the next class. Keep having fun, keep learning. We'll make one video on the changed pattern of the JEE. Okay. Till then, take care. Bye bye. Thank you.